Hi, we're live at Mobile World Congress, where some of the most important innovations are happening in platforms and infrastructure. Today I'm talking to Cristina Rodriguez and Chandresh Ruparel, and we're talking about edge to RAN and to core, and we're also talking about the journey from 5G to 6G. So I guess to start things off, we're seeing a lot of things happening with AI. It's changing the way traffic is moving on our network. We're also seeing transformation in terms of the workload. So perhaps that's a really great place to start. I'd like to ask you, what does this mean for Intel and the processors supporting this?
AI, of course, AI is everywhere, and we know it's going to be everywhere in the future. And we have the solutions. We're working on our roadmap to be able to provide to our customers the right capabilities without having to increase the complexity. Our Xeon 6 SoCs, Granite Rapid D, and we have now two versions. So last year, we launched the 42 cores. This one is now 72 cores. So we're talking about a SoC, Xeon 6 SoC, Granite Rapid D, that is capable to have quite amount of performance, 72 cores, up to 72 cores. Very low power, so performance per watt, very good. But then in addition to that, we have the acceleration that we have talked in the past, the VRAM boost, so perfect to deploy in the RAN. And then we also have, and this is critical to your question, we have built-in artificial intelligence, AI built in. And the way we do that, we have an acceleration, our advanced matrix extension, AMX, which allowed to do that workload, the AI workload, very efficient, again, very low power, without having to add complexity. With that, now we have an SoC that you can deploy in the RAN. You can do all the inference that you can possibly need to do in the RAN. At the same time, we're talking about edge. And I'm quite excited about edge and what that means for enterprise, for both telco and enterprise. But similarly, you can deploy at the edge a CPU in a server that is able to do AI right there. Now you can process the data right what is being generated without having to go all the way to the data centers and come back. And again, you have that capability because we have that AMX right there built in the CPU. You can do AI inference right there at the edge.
Chandresh, I want to come to you now. What are the critical requirements that service providers are asking you for in terms of sort of security and other aspects just to address these new AI requirements?
So the mobile operator requirements are fairly straightforward from an infrastructure standpoint. And the first fundamental requirement is TCO improvement from gen to gen, which effectively means that the performance improvement has to be there. In addition to that, power efficiency has become very important. So power efficiency is important not just for sustainability reasons or some basic savings in CapEx or OpEx. It is becoming even more important with the advent of AI. There is a concern that the power consumption is going to go even higher. And then the third one is security. Increasingly and more urgently, mobile operators are asking for more security at element level, which means communication between applications or elements has to be encrypted, and sensitive data and applications must be isolated. And this is because the AI-driven threats have increased. There have been hacks where it's not just data that is being stolen, applications are getting spoofed, creating a higher risk for carriers. And finally, they're looking for AI use cases in the core that are with cost-effective solution. And let's take each one of these into perspective. Intel Xeon 6 with E-cores has been broadly adopted by the ecosystem. Some of the critical reasons that drive these decisions are, number one, it's a highly performant solution. Our ecosystem partners have established that when you compare it to existing deployed solution base, you get 3.2x plus improvement in performance. And keep in mind that vast majority of mobile operator infrastructure in the core is deployed on Intel Xeon. Now, the second one, power efficiency. Again, our ecosystem partners have been able to establish that the improvement or reduction in power consumption is more than 60% going from the deployed base to the Intel Xeon 6 E-core based platform. If you take Intel Infrastructure Power Manager into account, that's a technology that we have worked over the last few years with our partners, is supported by ISVs, and currently it's in mobile operator field trials. In fact, in one of the most recent field trial, this is production field trial with live traffic that lasted about 3 months. Consistently, the average power saving was more than 35% at a platform level. And this is something that we have seen consistently across all the trials, tests, validations that carriers and our partners have done. This makes it the most power efficient solution in the market when you combine Intel Infrastructure Power Manager and Intel Xeon 6 with E-cores. On the security front, as I mentioned, isolation of application and data, as well as encryption of all communications between elements and applications. When you implement security, the performance takes a hit. And that's been a concern forever. And now the carriers are saying perimeter security is not sufficient. So this is where Intel's Zero Trust architecture comes into play. We have capabilities built into the silicon that allow you to deliver performance security. You get 8x the performance with Intel Quick Assist technology for crypto. So when you encrypt, decrypt, your performance significantly improves and you are able to leave more compute cores available for your application capacity. Similarly, the trust domain extension, Intel technology, allows you to isolate applications and data and reduce the attack surface significantly. And finally, on the AI front, as Cristina mentioned, live inferencing, analytics, you can actually do this. One of them being demonstrated here at MWC, anomaly detection, network performance analytics, network function load analytics, subscriber experience, etc. And what we have found is that majority of the use cases require less than 10 billion parameters. You can easily deploy this with the same server config as you are deploying for your 5G core infrastructure. Makes excellent cost-effective solution because you don't need GPUs, you don't need to inventory, manage, truck roll additional configs.
So here on the Intel stand, you've got some amazing demos set out this week at Mobile World Congress. Perhaps you could start off by telling me about the sort of RAN and edge demos that you're showcasing this week.
We have quite a bit of demos both in the RAN side and in the edge side. In the RAN side, remember now we have an SoC where you can do AI and also you can reduce the amount of servers that you need to deploy. We have, for example, Ericsson and Red Hat showing agentic AI for link adaptation efficiencies and just in general radio efficiency. We have Samsung doing quite a bit of AI, both in the spectrum efficiency, but also in power management. I have mentioned before, probably to you, Ruth, our capabilities with the C and states in our CPUs, in our Xeon CPUs. And now we're taking that to the next level because now we can apply AI, the built-in AI, AMX AI that we have in the SoC, we can apply it and take it even to the next level. We have Rakuten and Dell with a ruggedized design, super important for deployment. We have SKT doing also some interesting pooling algorithms. And the other one that we have, the Cisco Unified Edge Platform. Cisco launched this just in November, last November. And you can do the processing of your data right there in the enterprise. So think about what all the video processing, facial recognition, voice processing that you could do at the edge. And we have one of the coolest things. We have a hologram, that you can do and interact with it. So we're showing the capabilities that we're bringing. We have Xeon 6 SoC, Granite Rapid D, all the way to 72 cores. with AMX integrated, the AI built in, with Ethernet also built in. I have talked about this before, 200 gig of Ethernet, and all the acceleration for VRAM, the VRAM boost. Also all the security built in, very good, high performance, low power consumption, low complexity, same architecture that you can deploy from core to RAN to edge.
Chandresh, have you got any others that you can tell us a little bit more that's going to beat some of Christina's?
We are demonstrating the zero trust architecture elements with Nokia on Intel Xeon 6 E-Core. We have Quick Assist technology that is showing 8x improvement in TLS handshake performance. This is, again, encrypted traffic that you are dealing with, so the performance hit is pretty high. And what that effectively means is that if you have a set number of cores and a set subscriber support that you're able to get with QAT, you would need to, for the same number of subscribers, you would need 8x the number of cores if you don't use QAT, which is a significant penalty. And these cores can be freed up for application capacity, as I mentioned. The second demo that we are showing, so the first one is with Nokia and HPE that we're showcasing. The second one is with Samsung and HPE, and this is where Samsung is showing anomaly detection and inferencing, again on Intel Xeon 6 with E-cores. And what it is highlighting is that this can be easily addressed with the same config that they're deploying in the network. And finally, the third one is with Ericsson, where they are demonstrating further improvement in performance per watt with Xeon 6 Plus. This is our next generation silicon. This is delivering 60% plus performance per watt improvement and 30% increase in performance for the same number of cores, which is a phenomenal result. And this is, again, with 5G core workload. We always use the real workloads, whether it is internal benchmarks or external, because that really becomes the best representation of what carriers can get in their networks.
The last question I want to ask you about, you both spoke about the fact that the Xeon 6 has been the most deployed for the 5G generation and mobile. How do you see it moving on as we what's the path to 6G? How is it going to evolve, and how do you fit in?
Yes, no. We have been very intentional in our roadmap from 10 years ago. Mm-hmm. Every generation we have bring performance per watt leadership, we have bring more acceleration, we have bring more security. And that's what we're going to continue doing. So we have again, very intentional on our roadmap to make sure that generation over generation, we have what our customers need as far as performance per watt, power consumption, security, AI, all built in, so our customers can be successful and have the best outcome of the network. Our CPUs have been the most deployed in 5G, but this is the foundation for 6G. Right? So what is next? So now we're starting to talk about what is needed for 6G, and we believe that what we have today with the Xeon 6 series is the foundation to that 6G path.
Fantastic. So Cristina and Chandresh, thanks for chatting with me today. It's quite exciting hearing about what you can already do with the Xeon 6, but also what the future roadmap is for future generations. So thanks very much.
Thank you.
Pleasure. Thank you.